great first question, great calculus question here. So it's question 1. Can look at question 2 here. It's asking how many solutions do the linear equations have. So I have here y equals 2x minus 5, and I have this here 8x minus 4y equals negative 20. So think about this problem here, and we're talking about how many solutions do this linear equations have. So how would we figure out this systems of SLE, systems of linear equations? What we have to do is we have to put it into the same form, right? We're going to put it into the same y-intercept form. Or you can use substitution or elimination to figure out the solution here. So for in this case, I would probably use substitution, but you could use elimination as well, depending on what you're more comfortable with. I'm personally more comfortable with substitution, so I'll do that. But the solution here might use elimination as well. So take a moment to think about this. I have basically, I'm going to say this is equation 1, and this here is equation 2, and I have to figure out how would I use substitution here to figure out my a variable first. So remember I have two equations, I have two unknowns, which means I can use this substitution or elimination to eliminate a variable first, and then I can solve for my one variable. So take a moment to think about this problem, and we'll take it up in a minute. So let's use, in this case I said I'm going to use substitution, right? So I'm going to basically sub 1 into equation 2. I'm substituting equation 1 into equation 2. So again, why I choose 1 instead of 2 is because in equation 1 here, I'm already isolating from my y. My y is already left alone here. I don't have to use algebra to manipulate this equation for me to isolate for something. So basically, I'm going to sub 1 y into 2 here. So which means I'm going to get basically equation 2 is going to look like this. It's going to get negative 8x minus 4, and my y here is now 2x minus 5, right? I'm going to substitute y 1 into 2. So I'm going to have 2x minus 5 here, and this equation is going to equal negative 20. As you can see here, 2x minus 5 here derives from this, it comes from this first equation here. And all I have to do here is now solve for x, right? I can do distributive property to expand the brackets here. So I have negative 8x minus, again, 8x again, minus 4 times negative 20 is positive 20 equals negative 20. Negative 8x minus 8x here would be negative 16x plus 20 equals negative 20. And then what I can do is negative 16x plus 20, I can move 20 to the other side. I can say that negative 16x equals negative 20 minus 20 here would equal 40, right? So minus 20 minus 20 minus 20 is 40. And then finally, x here would equal basically 40 over 16, over negative 16, right? Or negative 40 equal over 16, which will basically, if I reduce this to lowest terms, this would be, let's see, I can divide both by 8 here. I would get 5 over 2. So this here is x equals negative 5 over 2. And then what we can do is we can substitute this x value for any of these equations here. So negative 5 over 2, I can substitute it into my first equation. So I can sub x equals negative 5 over 2 into 1. And I can say that y here equals 2 times negative 5 over 2 minus 5. So now I'm solving for y here. Y is now 2 times negative 5 over 2 here would be simply negative 10 over 2 minus 5. Y here, this here simplifies to negative 5 minus 5. This here, y here equals negative 10. So this here is my point of intersection. You can say that this systems of linear equations, SLE, has one solution, and it is in the points negative 5 over 2 and negative 10. And this here is my solution for this problem. And let's see what they did here. So it says we have a simple sisters of linear equations, which is good, which is further simplified, so they can check for systems of linear equations. Now in our problem, we have 2, -1, and -5. Okay, so they're actually rewriting this as a matrix, or as a matrix here, and they're trying to solve, and basically they're using systems of linear equations to basically solve for if it has one solution, a unique solution. So like I had here, no solution, or infinite many solutions as well. In this case, they wrote here they have a systems which has a unique solution, and I actually went a step further and I solved for the systems of linear equations. So this here has one solution, and which is the exact same thing as unique solution. And I think this question was also just asking how many solutions. So I think the solution is fine. So solution is correct. Good analysis here. And basically it's a topic of, you can think of this as a grade 10 problem where we're talking about the point of intersection between two linear lines, or you can think about this as a linear algebra problem when we're talking about systems of linear equations. We could rewrite this as a 2x2 matrix, and then basically solve for the matrix here to basically solve for x and our values, to solve for whether or not it has indeed basically one solution, no solutions, or infinite amount of solutions. Again, depending on what this means here, if I show you visually, if I have 2 points here, they can basically be parallel lines. So again, I have no solution in this case. They can intersect at some specific point here, which means it has one solution, or you can say unique solution. And finally, it could be an infinite solutions if both lines directly overlap each other, right? If both lines are the exact same lines here, this will have an infinite solutions here, because they're all the same lines. In this case here, no solutions here is an inconsistent, and both these guys here are consistent. So don't worry about, if you don't know those terms, these are kind of this here is introduction to linear algebra, so don't worry about that. But we can also just think of this as a grade 10 problem here. So say solution is correct, good analysis here, and basically we're just finding the point of intersection for two lines. You could think of this as that concept as well.